All right, section 5.3, solving quadratics by graphing and factoring. So mainly it's going to be by factoring. We're going to start off on the first example by showing you how you can do it with a graph. But for the most part, it's going to be factoring here. Usually that's faster. So we have a couple vocab words here in the beginning. It says a zero of a function is the x value that makes the y value, or f of x, equal to 0. So remember, any equation, when it says f of x, it really could be looked at as just y. So that's just the y value. The zeros of a function are the x-intercepts on the graph. So unlike other functions, unlike linear functions, which only have one zero or one x-intercept, quadratics can have two. They actually can have 0, 1, or 2. And then we get into like real zeros and imaginary zeros and stuff like that. These zeros are always symmetric about the axis of symmetry. And the solutions to a quadratic equation in standard form, when you set them equal to 0, are called roots. So pretty much these two words a lot of time get used interchangeably. There's probably, I think roots are when you're referring to the algebra part of it, and zeros are when you're referring to the graph. But you can kind of think of these two as one and the same. They're basically the x value when y equals 0. So that's how you want to think about it. X value when y equals 0. All right, so let's go through and let's tackle this first example. And I'll show you both ways. We're going to show you by factoring, and then we're going to show you by graphing. So by graphing, so remember, right now this thing is in standard form. So whenever you want to graph something in standard form, the first thing you need to do is you need to find the axis of symmetry. You need to find the x value. And it's negative b over 2a. So since b is positive 2, I'm going to have negative 2. A is 1, so 2 times 1 is 2. So it looks like I have x equals negative 1. All right, so if x equals negative 1, now I want to figure out what y is. So I'm going to stick negative 1 in there and figure out my y value. It's f of negative 1, actually. So let's go through and do this. So we have a negative 1 squared plus 2 times the negative 1, take away 3. Be very careful with parentheses on these. So a negative 1 times itself is just positive 1. And this would be minus 2 minus 3. 1 minus 2 minus 3 is negative 4. So it looks like we have a y value of negative 4. So what that does, that locks down my vertex. So I now have a vertex at negative 1, negative 4. So let's put that on the grid. Negative 1, negative 4. Luckily for us, when I go back to the original equation, the a value, or the coefficient in front here, that's a positive number, so I know it's going to be concave up, so it's going to go up. And there's no stretch factor, so I know it's going to follow the typical curve, which is over 1, up 1, over 1, up 1, over 2, up 4, and over 2, up 4. And if I want to do one more, we go over 3, up 9, and over 3, up 9. And I graph it. Whoop, missed my mark a little bit there, but you can imagine where it's supposed to go. So what we're after, what we just found right here, these two values are the zeros for the equation. All right, so they're the zeros there. So I have zeros at negative 3, and I have zeros at negative 3 and at positive 1. All right. All right. So basically what that is it solves the equation when y is 0. Those are my two x values. So they kind of make that equation true when the y value is a big 0 there. All right, so if you're going to factor using algebra and you're looking to find the zeros, here's what you do. You set up your quadratic, you set it equal to 0. This is what you do anytime you're trying to find the zeros. Set it equal to 0. And always try to factor first. Before you try to graph, always factor first because it's usually faster and easier. So we play the game, and I'm like, well, I got to find two numbers that can multiply to make -3, but then they need to add to make +2. So I think if I choose my numbers right, I think this will be the combination, x plus 3 and x minus 1. Now, we haven't solved anything yet. Remember, these two things right here, all these are just factors. Now, I'm going to use something that I refer to as ZPP. All right, ZPP. And it stands for the zero product property. And according to the zero product property, it doesn't seem very, like there's not a lot to it, but it basically says if A times B equals 0, well, if two numbers times together equals 0, then either A must equal 0 or B must equal 0, or both. You know, they could both be 0. But one of those two dudes got to be 0. So I'm going to apply ZPP up here to these factors because I have these two things that times together to make 0. You know, I have this blue parenthesis, if that ends up being 0, or if the red parenthesis. So what you want to do is you want to basically figure out, well, when is this going to equal 0? When is x plus 3 equal 0? Well, this one's pretty easy. You probably could just look at it and say, well, when x is -3. And the red one, you know, when is x minus 1 going to equal 0? Well, when x equals 1. So you'll notice that those are the same two solutions that we got from our graph. All right? So you can do it by factoring using algebra, or you can do it by graphing. The rest of this problem, or this sheet, we're going to focus more on the factoring part. So let's kind of keep moving down. So it says find the zeros of, and we got a couple equations here. So I'm going to move a little bit quicker. So first thing is I set it equal to 0. I need to find two numbers, times together to make 12, add together to make -8. You might get to them really quick, but I'm going to list out the factors of 12. You got 1 and 12, 2 and 6, 3 and 4. I think 2 and 6 could work, especially if they're both negative, because I noticed that middle term is negative. So now -2 times -6 is the +12. Added together, I get my -8. And just solving these kind of quickly in my head, that first parenthesis is 0 when x equals 2. And the second parenthesis is 0 when x equals 6. So there's two possible solutions to that quadratic up above when y is 0. This one, you'll notice it's kind of weird because we're like, hey, we're missing this back number. So a lot of times when you're missing that back number, the best thing you're going to be able to do is you're going to be able to pull out a GCF. So I'm going to yank out a 3x out of both pieces. 3 is the biggest number that comes out of the coefficients. X is the smallest variable piece I can take out. So reverse distributive property, I would have an x plus 4. So it's kind of like I have two parentheses here. You know, this parenthesis, when does that equal 0? Well, that's when x equals 0. And then this one is when x equals -4. So those are the two answers for that one. Kind of a similar idea over here. Find the roots of, or basically I guess I could have just said, because the roots imply that you're zeroing somewhere. I could have just said solve this thing. So I could do 9x squared minus 1. So set it equal to 0. All right. Sometimes you got to manually do that. Like on this problem, I had to manually move the 1 to the other side and set it equal to 0. Well, I notice I'm missing the front number. So I believe this one, a lot of times when you're missing that front number, this is the difference of squares. So this is the difference of squares, and we spent some time factoring, practicing this. So to get the front number, 9x squared, well, that's going to be a 3x and a 3x. And then I'm going to have a plus 1 and a minus 1. And that way the middle term will go away. So that way I'm going to get what we're supposed to get. Now this one's a little tougher because I may have to actually solve this. So I may have to actually set this one up and say, well, when is 3x plus 1 going to equal 0? And I minus 1 to both sides. And then I divide both sides by 3. And I'm going to get x equals negative 1/3 as one of my solutions. Now this other side, when is 3x minus 1 going to equal 0? Well, it's when 3x equals 1, divide both sides, so I get positive 1/3. So my roots there, or solving the problem, negative 1/3 and positive 1/3 will get me there. Now there was also another way to solve this problem using square roots, but I'll kind of save that for a later lesson. All right, next one. So we're trying to solve this equation. I notice it's a quadratic, so first thing I should do is set it equal to 0. So we're going to get 0 equals, and I need to put this on the other side, so it's going to turn negative. And I'm going to write this in descending order. So I put the x term in the middle where it would normally go. And then I kind of look at this and I'm like, well, wait a minute. This is going to be a little bit trickier game than usual, because I'm probably going to have to maybe use bottoms up unless I could factor something out and end up with just an x squared in the front. But I don't think so. So I'm going to go off the grid on this one so I got a little bit more room. So 8, negative 40, and 50. So 8, negative 40, positive 50. All right, when are you going to equal 0? Well, first of all, I try to pull out a GCF. I can pull a 2 out of all those, but I don't believe I can pull anything bigger. I think the greatest common factor, so the GCF is going to be 2. So let's yank a 2 out, and I'll have 4x squared minus 20x plus 25 equals 0. Now I think because I have this 4 in the front and a is not equal to 1, so remember this is my a. Well, if a is not equal to 1, I'm going to bust out bottoms up. So hopefully you remember that from our little factoring unit we did. So bottoms up is going to look something like this. Step 1 is I multiply a times c. So I'm just going to have x squared minus 20x plus 100, because 4 times 25 is 100. Now I play the normal game. So we're going to play the normal game here. Two numbers times together to make 100, add together to make negative 20. So the ways to make 100, 1 and 100, 2 and 50, 3 doesn't go in there, 4 and 25, 5 and 20, 6 doesn't go in there, 7, 8 doesn't, 9 doesn't. I get 10 and 10. I think that's going to be my combination. It looks like if I do negatives of both, so I'm going to have x minus 10 and x minus 10 equals 0. Well, 0 product property. If 2 times something equals 0, either you're 0 or you're 0. And they're both the same. So x equals 10, and x also equals 10. So your two zeros or your two solutions could be the same number. And how that happens, if we were to graph this, all right, if we were to graph this thing, and basically what I know is, instead of touching twice, this thing's going to come down somehow, and it's going to just touch right here at the x value of 10. All right, and when that happens, we refer to this as a double root. All right, we have a double root occurring at 10. Most of the time you come down, you hit, and you get 2 roots, or you're floating up here and you got no real roots. This is one of those rare cases where you get a double root. All right, so when there's kind of like a perfect square going on. Oh, actually, check that. I got a little bit ahead of myself. I forgot the bottoms up part. The bottoms up part, remember, I didn't do the bottom. We got to go back and we got to divide by A. So I forgot to do that. So then I need to, man, I'm glad I caught myself. Then I need to reduce that, which is 5 over 2. And 5 over 2. Whew. All right. And then, so right now, I could bottoms up it, and I could do the 2x minus 5. But I think for what we need, you know, we're just trying to figure out ZPP. One of those two equations have to come out to be 0. So I think it's actually going to be positive 5/2, or AKA 2.5 is actually going to be the solution to this one. Let's just graph this thing and see what happens. I'm kind of interested to see. So we have 8, negative 40, 50. So I think I'm going to change my original thought to not a double root at 10, but a double root at, so coming down somehow, at 2.5. Actually, I could see that the y-intercept is going to be at 50. So this is going to be kind of a crazy one. It crosses way up here at 50, but my x's are kind of tight. So let's see if we can do this on our graphing calculator. 8, negative 40, positive 50. All right. Move it out of the way here. So let's turn it on. Y equals, clear that out. And we're going to have 8x squared minus 40x, because I had to move it to the other side, plus 50. Enter. And let's make our window. We'll keep the x's tight from negative 5 to 5. And the y's, we know it goes all the way up to 50. So I don't know. Maybe I'll go like negative 50 to 50. That's 100. Oop. Negative 50 to 50. That's 100 spaces. So maybe we'll go by tens. And let's try it. Boom. And I think right there at 2.5 is going to be it. What we could do is we could do the second calc. And let's do number 3, because this is a minimum. And the left bound, I just got to be on the left side. So, yep. And we go over here to the right side. Yep. Guess? Sure. X equals 2.5. Yep. So 2.5 is where we cross there. And we could also probably verify it on our table if we wanted to zoom in and like start at 0 and go by 0.5s. And then I go second table. We could check it out and we could see, yep, right there at 2.5 gives me a 0. So we're good to go. And it only happens once. All right, good stuff. Keep on going. If you know the zeros of a function, you can work backwards to write the rule. So think about how we just solved the problems. If we have a 0 of 2 and a 0 of negative 1, that means a 0 of 2 meant this must have been a factor. X minus 2 had to have been a factor. And x plus 1 had to have been a factor. Because when we set them equal to 0, it's the opposite of what you would think. So if those two were the factors, I could then multiply it out and, you know, get x squared. Would that be plus 1x minus 2x minus 2? So x squared, combining like terms in the middle, minus x minus 2. So this function right here would be the original function to where I get my zeros. So it's kind of like you can start with the function and then go find zeros, or you can start with the zeros and go find the function. You should be able to work back and forth either way. All right, an object is thrown or launched into the air, such as a baseball or a soccer ball. It's called a projectile. So projectile motion is modeled by quadratics. The general function that approximates the height, h, so this is our height, and the height is a function of time, meaning you plug a time in and you'll get a different height. So it's a function machine for height with inputs of time. On Earth, after t seconds given below, so t is our seconds, that's our time. The model does not account for air resistance, wind, or other real-world factors. All right? So this is kind of like in a vacuum. And I can already see on my notes I screwed up. Add a t right here. There's supposed to be a t after that v sub 0, or v naught, they call it. All right, so let's kind of explain this. First of all, the negative 16. This has to do with gravity, and that number only works on Earth. And it only works for feet. All right? If we're talking about meters, it would be a different number. So in physics, you might use a different front number there. V sub 0, this is the initial velocity. You know, how hard am I kicking or throwing the ball? Or if it's free fall, you use 0. Yeah, you don't even, that term's gone because your initial velocity is 0 if you just drop something. But if you're throwing something, it's going to have some sort of force. And then h sub 0, this is going to be the initial height. All right, aka it's the y-intercept. So you think about this, you have some sort of a graph. It's all going to be in quadrant 1 because your time is not going to be negative. Your height is either on the ground, which is down here, you know, a height of 0, or you're going to go up in the air, and you're going to launch something. If you launch it from the ground, you start at 0, it goes up, and it comes back down. All right? Or if you launch it off the top of something, all right, maybe you're on top of a building, well, you have a y-intercept where you're starting at time 0 at a certain spot, and then it kind of goes up and does its thing. All right, so that's what's happening. Let's try to solve a problem here. It says a soccer ball is kicked from ground level. So this is our initial height, aka h sub 0. Initial velocity of 32 feet per second. So our v naught is 32 feet per second. Our initial height is 0 because we're on the ground. So after how many seconds? So this is basically saying find t, will the ball hit the ground? All right? So let's think about our function here. So the height is negative 16 t squared plus v sub naught t plus initial height. And we're trying to figure out t, all right? And the big thing we're trying to figure out is when the ball hits the ground. Well, the ball hits the ground when it's 0. It's basically the 0 of the function, when the height is 0. And it should happen twice. It should happen 2 places on this one. So let's fill in what we know. We have negative 16 t squared. We know that the initial velocity was 32. And we took off from the ground, so since this is 0, there's no back number. So this is one where it's not a trinomial. We're just doing a binomial. So I think we're going to be able to just do the greatest common factor. It's actually going to be easier. So let's see what we can pull out. Well, I always want to pull out a negative if I can to make my front number, my front t squared, just t squared. And it looks like I can yank a t out. So I'm going to yank a negative 16t out. And what I'm going to get is I'm just going to have a t right here. And it looks like it's going to be minus 2. Because negative 16t times negative 2 is positive 32. Well, now we're going to use ZPP, zero product property. So this is 0 when time is 0. All right, that's not very interesting. We already knew that at time 0, we're going to have a height of 0. This is the one that we want. And this problem worked out really nice because at exactly 2 seconds, the soccer ball will hit the ground. All right, so we had some really friendly, nice numbers here to kind of help us out, but that would be a way to solve that problem. Now, if there was another initial height in here on the back side, we would have had to do a normal factoring, get the 2 parentheses, maybe use bottom up, maybe not, but that'd be how we'd have to do it. All right, hopefully this will help you out with the practice. You got some basic problems, you got some word problems, maybe a little SAT mixed in there. All right, hopefully this helps you. See you.